Okay, so for number 2 here, okay, we are looking for the apparent weight. Now, which force is apparent weight? Normal force. Okay, so we're looking for Fn. Ooh. Once again. All right, so we are looking for normal force. Okay. And we are going over the top of the vertical circle. Okay, so in this position, gravity acts into the circle and normal force or apparent weight is acting out of the circle. All right, so we need to remember that for forces in minus forces out. Okay, we know the mass of the person is 75 kilograms and they are traveling at 22 meters per second and the radius of the circle is 150 meters. Okay, so we know quite a bit of information here. We are looking for the apparent weight. So Fc equals forces in minus forces out. Okay, and that's going to mean, okay, Fc equals the force of gravity minus the normal force. Now, when I do one of these questions, I always want to solve for a positive number. Okay, a lot of people will just subtract Fg over to this side and solve for Fn, but what they don't realize is they're not solving for Fn, they're solving for negative Fn. And then they get a negative number and they're not sure about their answer. Okay, so what I always do is I move Fn over to the other side so that it's positive. All right, so I have Fc plus Fn equals Fg, and then I subtract Fc over to the other side. That gives me positive Fn. If you do it this way, you should not get a negative number. Okay, like if you get a negative number for Fn, it means that somehow the track was pulling the car in, right? And that's not the case. All right. So now that we have that, now we can do our calculations. We have enough information to calculate Fg because we have M, Austin, and G, okay? And we have MV and R, so we can use MV squared over R. All right, so that's what we'll have. We'll have M times G plus MV squared over R, so it'll be 75 times 9.81 plus 75 times 22 squared divided by 150 meters, and that should give us 4.9 times 10 to the 2 newtons. Right? So this person definitely feels lighter than normal. Question? Yeah, when it says that, it means radius. When they describe a circle, by default, they describe radius. So unless they actually say the circumference of the circle is this, or the diameter is this, we default to, we were given radius. Yeah, sorry, that would definitely interfere with your calculations if, yeah. All right, so if they tell you it's a 150 meter circle or it's a 200 meter circle or whatever, okay, that's the radius of the circle. Yeah? All right, questions on how that one worked? Okay. Okay, try this one about the vomit comet. If you're apparently weightless, what's your apparent weight? 0. So what's the normal force in this case? 0. Okay, that's the first thing you have to realize in order to even really start this question, is that the normal force in this question is 0 newtons. Okay, we are going over the top of the vertical circle, so that means normal force would be acting out if it was present, but it's not. Okay, that means the only force that is present is gravity. You're a projectile. That's why you're apparently weightless. Okay, gravity is the thing that's causing you to move in an arc, okay, that will eventually re-encounter the ground. So if we're looking at this from a forces in minus forces out standpoint, Fc equals forces in, gravity. There aren't any other forces. So that's it. That's where we leave it. Okay, mv squared over r equals m times g. Right, and we just manipulate for the radius, right? That's what we're looking for. Yeah, we're looking for r. So we're going to bring r over here, and then we're going to divide both sides by m times g. Okay, the m's are going to cancel, and we're going to be left with v squared over g equals r. So we'll take our 210 squared and divide that by 9.81, and that will give us our radius. And it's going to be big, because this is a big circle. I think that was the answer on there. Yeah, okay. This was the last one we must have done in period 3 on Friday. Okay, 210 squared divided by 9.81. All right, so we got 4.5 times 10 to the 3 newtons. So it's a 4.5 kilometer radius circle. All right, but I mean, this is a plane, right? It's a big circle. Okay, so 4.5 times 10 to the 3 meters. Okay, so again, guys, all these vertical circular motion questions break down to the same thing. Essentially, a free body diagram so we can identify what forces are in, what forces are out, and then manipulate forces in minus forces out for whatever it is we're looking for. Okay? Any other questions on that one? Okay, now I've got a few practice problems out of the workbook, the digital workbook for this unit that I want you guys to work on. Okay, and if we're feeling comfortable with those, then we'll definitely be able to move on to gravitation by Wednesday. Okay, so you'll need the Unit 3 worksheet book, okay, and I think it's on page 4, if I recall. Nope, sorry, it's on page 2. Starts on page 2. Okay, so vertical circular motion worksheet. Okay, so you can start there. They start out pretty straightforward, and then they're going to get a little bit more complex as you go along. Okay, if there's any there that give us trouble, then let's ask, and we'll walk through them together. The force required to break this string is 186 newtons. That means that's the maximum force that that string can exert. Any more than that, and you don't have an object going in a circle, you have an object traveling in a straight line. Okay, because there won't be any centripetal force. Okay, we have a 1.5 kilogram mass tied to it and whirled in a vertical circle with a radius of 1.9 meters. What is the maximum speed it can be whirled at without breaking the string? Okay, where is the string most likely to break? At the bottom. All right, so that's the first thing you have to know in order to answer this question is we are dealing with the bottom because that's the place where the most force would be required. Okay, so we have this thing on a string, okay, and it's moving along the bottom of the vertical circle. That means gravity is pulling out and the tension, which we were given, is pulling in. Okay, so now we can set up FC equals forces in minus forces out. Okay, and so we know that we have mv squared over r equals equals tension, which is 186 newtons, okay, minus m times g. Okay, we're trying to figure out the maximum speed, so we're looking for v. So we got to manipulate by bringing r over to this side and then dividing both sides by m. M does not cancel, okay, and then we want to square root this in order to get v. Okay. Everybody with me there? This becomes more of an order of operations problem than it does like you knew what to do. Most people kind of understand what to do. It's getting this entered in the calculator correctly. Okay, so we have 186 minus 1.5 times 9.81 times, what was the radius of the circle? 1.9 meters. Okay, and then we divide that by the mass, which was 1.5. Okay, so 186 minus 1.5 times 9.81. All right, multiply that by 1.9. Okay, divide that by 1.5, and then square root it. All right, so our maximum speed, 14.7 meters per second. Okay, because it will definitely break at the bottom. Okay, any other ones giving us trouble that we need to go over? Everyone's okay with these? Okay, I keep working, you still got about 10 minutes. Tomorrow's quiz will be 2 vertical circular motion problems. Okay, we'll kind of use that to tell me whether or not we need another day on vertical circular motion or whether we should do the assignment tomorrow and move on to gravitation on Wednesday. All right, we'll use our performance on tomorrow's quiz to kind of decide that. All right, so make sure you have a look at tomorrow's quiz tonight when I post it, okay, right after school. All right, keep working on those problems for now. You still got another 10 minutes. Okay, so artificial gravity question. Is there any vertical and horizontal in space? No, so it's not a vertical circular motion, it's a trick. Okay? It's not a vertical circular motion question, that's the trick to it. Okay? If we want to feel gravity produced by spinning a space station around, then Fg needs to be our Fc. Okay, we want our centripetal force, which is actually provided by the normal force of the floor, to feel like real gravity. Okay, so even though this is really normal force equals centripetal force, it's gravity that we want normal force to feel like. Okay, so we end up with, again, mg equals mv squared over r. Okay, and then we're solving for how fast it has to rotate. So we're solving for v. So we'd multiply both sides by r, divide both sides by m, it cancels, and then square root. And again, we're left with the square root of GER, okay, just like we always are, it seems anyway. Okay, so we have 48 meter radius times 9.81 square rooted, and that'll give us our 22 meters per second. So it's not a vertical circular motion question. I just threw it in there to kind of remind you that our artificial gravity questions come up on tests and things. Sometimes, always. Okay. Hey, any other ones giving us trouble? Okay.